When I made the fourth installment in the series about analyzing the YouTube religious identity survey, I thought I was done. But something kept nagging at me, so I pressed on. I'm going to go through the principles of this new analysis in this clip, and then I'll show you the results in the next two. So if you're only interested in the results, go to the first and probably only video response down there. First, a reminder of the results from the last clip, where I tested every quality asked for in the survey against every other qualities. I could make a graph showing the connections found according to the analysis. Then I speculated that some of the connections could be indirect. For instance, the dependency between belief in life after death and belief concerning the age of the earth was quite a bit weaker than the connection between belief in life after death and stance towards creationism, and between creationism and age of earth belief. So maybe the dependency found between the answers to life after death and to age of earth simply reflects that there is an indirect connection. This is what's called conditional independence, a topic I talked much about in Reasoning Under Uncertainty number 13, Evidence About Evidence. If you got independence between A and C conditioned on B, that means that the connection between A and C can be explained by the connection between A and B and between B and C. If you know B, knowing A won't tell you anything new about C or vice versa. Now, if you want to explore how to describe a set of connected qualities like sex, religion, or belief in the afterlife, you need to organize the way you think about the connections. Usually, this is done by starting at one end and find a path from that quality to the next. So you got a directed graph rather than just connections, and you condition those qualities that has connections pointing at them by the qualities that points towards them. This kind of organization of dependency is called Bayesian networks or probabilistic networks. And I've got to warn you, I'm not a great expert about this field. Still, I can manage to handle them myself as long as there are only three qualities. Here are the possible networks for three nodes, as they're called in graph theory. Several of these graphs expresses the same dependency though, so we need to be a bit careful. These kind of directed connections are a bit easier to think about if we add some understanding to the directions of these connections. Cause and effect may be an expression that comes to mind, but people put so much different meaning into that phrase that I would rather avoid it. Often people think about a cause as something deterministic, that B follows A for sure, and that will not do for our purposes. While I did find that there was a dependency between gender and religion, with females being more probable to be Abrahamic than expected under independence, there are still atheistic females and male followers of the Abrahamic religions. Instead, I'll use the word influence, and what I put in that is that if you say that quality A influences quality B, then you think that if A was changed, you have reason to use a different probability for B later on compared to if that change didn't happen. So influence is a tool for describing why we have dependency. It's easy to make mistakes with dependency and influence though. If we find a negative dependency between savings and number of hours per week spent watching TV, you may think that you'll save more by watching less TV. But it could just as well be the opposite way, or perhaps more likely, your income influences both your savings and your TV habits. So if you find a dependency between A and B, A could influence B, B could influence A, or both could be influenced by another quality C, which we may or may not have measured. Also, what's meant by imagining that we change one quality and thus may influence another? There was a dependency between religion and gender. Now I would not expect to see a change in someone's gender just because they switched religious identity. Then again, if we imagine changing the plumbing and body shape of a person from male to female, would we have any reason to expect a subsequent change of religious identity? Hardly, I think. But there's a fairly little that affects gender. It's basically a genetic lottery. It may seem like we have no explanation for the dependency, but that's only because we imagine a change done in adult age. What we need to do is inject our counterfactual gender change much earlier, so that the imaginary person feel the full effect of having another gender, both via the biology and the upbringing. Is it now reasonable that gender can influence the religious identity? I would say so. I can't see any influence going any other way that can create such a dependency detectable even in our small dataset. Going back to 3 different qualities, it is now possible to think about influence going in several steps. If we found connections between A and B, A and C, and B and C, it could be that when we look at all 3, they are still all connected. But it could also be that there are only 2 connections. There are, however, several ways for that to happen. A and C could be independent, conditioned on B, or we could have that A is in the middle or C is in the middle. If we've got that A and C are independent, conditioned on B, then it could be that A influences B influences C, or that C influences B influences A, or that B influences both A and C. Still, if quality A is gender, we know which of these 3 alternatives we need to choose. In addition to conditional independence, we could have the opposite. If A and C are independent but both influence B, we've got another form of dependency structure between A, B and C than if A and C are independent conditioned on B. Also note that if A is gender and we are studying qualities with dependency towards gender, we now have the tools for determining whether B influences C or vice versa. A influences B influences C is different from A influences B and C influences B. In some instances, the influence can go both ways. If there is a direct connection between evolution and creationism, the influence could go one way at one time and another way at another time. Still, it would be weird if these influences were distributed exactly 50-50, so we could still identify a main direction of influence. One last thing before the results. Full Bayesian inference is very difficult in the case of more than 2 survey variables. It was hard enough for 2. On the other hand, there's a large number of non-similar models here. That makes frequentist hypothesis testing difficult too. Fortunately, there's something in between called the Bayesian information criterion. It applies the frequentistic tool of asymptotics to Bayesian probability. The result is a frequentist measure of model fit called the maximum likelihood, plus a term that penalizes complex models. The model with the lowest BIC wins. The criterion can be used for approximating the Bayesian model probability, making the connection between Bayesian statistics and Occam's razor explicit. Also, the BIC can be said to describe the information needed to transmit the model plus the data. So, the model with the lowest BIC means the most parsimonious description of the data. Next, the results.